Welcome to our channel Circuits Analytica. In this tutorial, we will discuss the computation of power consumed by a resistance. So we will start with current division rule. The current source Is is connected across two resistors of value Ra and Rb connected in shunt. Equivalent resistance of the shunt combination is Ra-Rb the whole divided by Ra plus Rb. Voltage drop across the shunt combination is Vs is equal to Is into R equivalent. So Vs is equal to Is into Ra-Rb the whole divided by Ra plus Rb. According to Ohm's law, current flow through resistance Ra is Ix is equal to Vs divided by Ra, that is equal to Is into Ra-Rb the whole divided by Ra plus Rb into 1 by Ra. So we will get Ix is equal to Is into Rb the whole divided by Ra plus Rb. Similarly, current flow through resistance Rb is given as Iy is equal to Vs divided by Rb, that is equal to Is into Ra-Rb the whole divided by Ra plus Rb into 1 by Rb. So we will get Iy is equal to Is into Ra the whole divided by Ra plus Rb. So this is current division rule. For the following network, find Ix, Iy and power dissipated by 3 ohms resistor. So we can find Ix and Iy using current division rule, and power dissipated by the 3 ohms resistance can be computed using the equation P is equal to I square R, where I is the current flow through resistance R. In this circuit, there are two current sources, a 12 ampere current source pointing upwards and a 5 ampere current source pointing downwards. So let us combine these two current sources to form a single current source of value 7 ampere. Now let us redraw the above diagram after combining the resistors connected in shunt. So 6 ohms resistance and 13 ohms resistance are connected in shunt, which can be replaced with a single resistance of value 4.11 ohms. Similarly, 20 ohms resistance and 4 ohms resistance are connected in shunt, which can be replaced with a single resistance of value 3.33 ohms. Now 4.11 ohms resistance is in series with 3 ohms resistance. So we can combine these two resistors to replace with a single resistance of value 7.11 ohms. Similarly, 3.33 ohms resistance and 7 ohms resistance are connected in series. So we can combine these two resistors to replace the resistors with a single resistance of value 10.33 ohms. Now this is our circuit. The given circuit is reduced to a circuit which consists of two resistors and one current source. So we can find Ia and Iy. Ia is equal to 7 into 10.33 divided by 7.11 plus 10.33. Application of current division rule. So we will get Ia is equal to 4.15 ampere. Similarly, we can write Iy is equal to 7 into 7.11 the whole divided by 7.11 plus 10.33. So we will get Iy is equal to 2.85 ampere. So now we have the values of current Ia and Iy. So this is the given diagram. Ia is the current flow through 3 ohms resistance and Iy is the current flow through 7 ohms resistance. To find Ix, we can apply current division rule. So applying current division rule, we will get Ix is equal to Ia into 13 divided by 13 plus 6. So we will get Ix is equal to 2.84 ampere. Now power dissipated by 3 ohms resistance is P3 is equal to 3 into I3 square. So P3 is equal to 3 into 4.15. So current flow through 3 ohms resistance is equal to Ia and Ia is equal to 4.15 ampere. So we will get power dissipated by 3 ohms resistance is P3 is equal to 51.57 watts. So Ix is equal to 2.84 ampere, Iy is equal to 2.85 ampere and power dissipated by 3 ohms resistance is 51.57 watts. Thanks for watching Circuits Analytica. Enjoy learning.